All right, today we're going to dive into something that is absolutely essential in the industrial world, API 570. This is the piping inspection code. You can think of it as the official rulebook that keeps plants and refineries safe and running smoothly. So let's break down what it's all about.
I want you to just picture the miles and miles and miles of piping inside a massive facility. These pipes are basically the plant's arteries. They're carrying everything you can imagine, often at really high pressures and temperatures. And if one of them fails, well, it's not just a simple leak, it can be a disaster. So the big question is, how on earth do you protect this huge, complex network?
The answer, of course, is a really solid, well-documented integrity program. And for that, the entire industry looks to API 570. It's the gold standard. For this explainer, we're going to break it down into three core pillars that make it all work. First, the organization, the people in charge. Second, the plan they create. And third, the execution, how it all gets done in the real world.
Okay, let's kick things off with pillar number 1, the organization. Before a single pipe gets inspected, you have to have a crystal clear structure of who does what. A plan is totally useless if you don't have people who are truly accountable for it.
Now, the code is super clear about this. At the end of the day, the buck stops with the owner-operator. They are responsible for the whole shebang, from building the inspection plans and doing risk assessments, all the way to making sure people are trained and even running internal audits to make sure the system is actually working like it's supposed to.
So inside that organization, you have the piping engineer. These are the folks who handle the hardcore engineering, the design calculations, the stress analysis, all the technical stuff. They're really the technical backbone of the entire program. And then you've got the boots on the ground, the authorized piping inspector. Now, this isn't just some random person with a clipboard. These are certified pros who are qualified to do the actual hands-on inspections and examinations. They are, quite literally, the eyes and ears of the whole integrity program out in the field.
Okay, so we know who's on the team. That brings us right to pillar number 2. How do they come up with a smart, intelligent inspection strategy? The heart of any modern inspection plan is a concept called risk-based inspection, or RBI. This is a total game changer. It moves way beyond just inspecting things on a fixed calendar schedule. Instead, it makes you ask two really important questions. First, what's the chance this pipe could fail? And second, if it does fail, how bad would it be?
And this slide just perfectly illustrates the difference. The old way, time-based, you might inspect a harmless little water line just as often as a high-consequence acid line. It just doesn't make sense. RBI lets you focus your time, your money, and your people where it actually matters the most, on the equipment that poses the biggest risk.
So how do you actually build this plan? Well, the code lays it out pretty clearly. You start by grouping your piping into logical circuits that have similar operating conditions. Then, for each circuit, you figure out the credible threats, like what could actually go wrong here. Based on that risk, you develop a targeted inspection plan, which then gets officially signed off by the team.
And we're not talking about a vague outline here. That plan has to be super specific. It has to spell out the exact type of inspection, the specific non-destructive tools you're going to use to see what's happening inside the pipe, and exactly where and when you're going to do those checks. It's a detailed blueprint for action.
This brings us to our third and final pillar, the execution. This is where the rubber meets the road. It's where that carefully crafted plan meets the real world, and inspectors get to work finding potential issues out in the plant.
A huge part of execution involves something called condition monitoring locations, or CMLs. Look, you can't inspect every single square inch of pipe. It's just impossible. So what you do is select strategic representative spots to take measurements. It's like taking a pulse. By tracking these CMLs over time, you get a really good idea of the health of the entire piping circuit.
And this diagram, which is straight from the code, really helps make this idea of CMLs concrete. What you're looking at is a high-risk injection point, where different fluids are mixing together. See how those inspection points, the CMLs, are all clustered right around that intersection? That's no accident. That's a smart, strategic plan to keep a close eye on an area where you'd expect to see accelerated corrosion. Now, one of the sneakiest, most frustrating problems inspectors have to deal with is something called corrosion under insulation, or CUI. It's such a major threat because, well, you can't see it. Water gets trapped under all that insulation and just quietly, silently eats away at the pipe. This is where inspectors have to become detectives. They're trained to look for really subtle clues. The code points out things to watch for, like insulation that's stained or bulging, or maybe areas near steam vents. All these little signs are red flags that scream to an inspector, hey,
You need to take a closer look right here.
Another spot that gets a ton of attention is the welds. You have to remember, every single weld is basically a seam in the system's armor. It's a point where the metal was changed during construction, and over years of service, these spots can become weak points for cracking or corrosion.
And checking out a weld isn't simple. An inspector has to think like a historian, right? They're thinking about how old it is, how it was made. But they also have to think about what's happening today. Is it subject to vibration? What's the environment like? All of these factors feed back into that risk assessment and decide just how closely that weld needs to be watched.
So as we start to wrap this up, the most important thing to remember is this. Piping integrity is not a project with a start and a finish date. It is a continuous, never-ending cycle. You plan the work, you do the inspections, you analyze what you found, and then you use that new information to make your next plan even better. It just keeps going.
And that really leaves us with one final crucial thought. The whole point of API 570 isn't just to check some boxes and pass an audit. The goal is to make sure the facility operates safely and reliably. So the question you should always be asking isn't just, are we compliant? But rather, is our program actually making us more reliable?